Okay, so I want to first kind of relate and remember what we guys had talked about yesterday. Okay? So first, yesterday we had our curves. We kind of, went to the normal curve yesterday. And so we talked about that, say, if you wanted to find the probability of getting, one of these pieces of data that's here in this section, then the way that you define the probability of this section is by whatever area it is. Okay, so we said, oh, you want to know what's the chance of getting something in this area? Well, then just like actually compute the physical area, and that then is the probability of getting data in that area. So the problem with that is that we don't know how to find area of curves, so they have calculus do that, and then we used some mathematician somewhere went and found all these numbers associated with that, and so then we go off of those values that the mathematician does, because we don't do calculus, so we use those numbers. Okay, so based on those numbers, we learned the anatomy of the normal curve. We learned that at the mean, how much, the z-score is 0, that's 0 standard deviations from the mean, so how much area is below the mean? Good, so this is 50% because that's half of the data. And so then let's say you go 1 standard deviation up. How much is between 0 and 1 standard deviation? Good, you remember is 34%. How much is between 1 and 2 standard deviations? This area here, 13.5%. And then from 2 to 3, 2.35%. And then finally, over here, what was our outside of 3? 0.15%. Okay, so those are the values we came up with yesterday. And finally, at the end of class yesterday, we talked about this girl that came to our class from another school, and we had to relate their grades to our grades. And so, let's kind of remember what we had done. We found that their class average was 50.5, and it had a standard deviation of 8.8. She got a score of 61. So the situation was that her score, remember from yesterday, was not an exact number of standard deviations up. It was, 1 and then part of another standard deviation up. So how did we determine how many standard deviations it was up? We found what's called the good. So the z-score, and you get that from doing your data. So you find this piece here minus the what? What do you find the difference between? To the mean. Okay? So your data to the mean, but I want to get that in terms of how many what? Standard deviations, so we divide by the standard deviations. So that was the formula we did at the very end of class to find the z-score, which is how many standard deviations you are away from the mean. Okay, so we stopped there. Now, what we're going to do today is take those exact same items that you found yesterday. Finding, this z-score. Say, Ileana, she was 1.19 standard deviations above the mean. Well, what if I want to know what percent of the class did she score higher than? Then that means I need to know what this area is. Well, we haven't discussed yet how to find the area below a z-score that's not on a whole number. Okay, that's what we're doing today. So, today we're going to find the area, which is the same thing as percent and probability, all that's the same, for any z-score, not just those whole number ones like yesterday. And we're going to do it in 2 ways. We're going to do that using a z-chart. So I'm going to teach you how to read the z-chart. And then I'm also going to teach you how to do the same thing on the calculator. You need to know how to do both of those methods. All right? And the 3 things we're going to find is areas that are below a point, above a certain point, and then in between 2 z-scores. All right, so let's get to it. I want going to start with the last problem from yesterday. Okay, so let's review. Our last problem from yesterday is about a married couple, and they worked at the same company, but they were in different departments. Okay, so you remember this situation? So the husband worked in one department, and the mean for the husband's department, the mean hourly salary or hourly rate was $12.80. Okay. And the standard deviation for his department was $1.20. All right, the wife was in a different area of the company, so she had different values. So the mean for the wife in her department was actually higher. So the mean for the wife's department was $13.50, and the standard deviation for the wife's department was $1.80. Okay, so the question was, how's the husband and wife doing respective to their average in their department? So like, who's quote unquote higher up in their department? Who's higher up in their own department? So who's better paid, the husband or the wife? The husband earns $14.60, so here's where we did the math for that. Here is his salary minus the mean in terms of the standard deviation, and so he was 1.5 standard deviations above the mean salary in his department. Okay, that's what this is. 1.5 standard deviations above the mean in his department. All right, then we got her data. She makes $15.75 an hour, of which the mean for her department was $13.50. Her standard deviation was that. So what would I say with this number right here? Her salary is what does this number mean? Bueller. Okay. Thank you. 1.25 standard deviations above the mean in her department. Good. Okay. So the next question that comes from this is something like this. Here's the question. What percentile is the husband located in his department? So that's the next question. That's where we take that from here. And do you remember what percentile is? If you're in the 95th percentile for height, what does that mean? You are taller than 95% of the people in your category. Good. So if we want to know his percentile, then we want to know at a z-score of 1.5, what percent of the employees in his department is he above? We need to know what percent this is. All right. And the way you do that is with calculus, so we don't do that, so we use the charts that the mathematicians made for us, and we use the z-chart. I'm going to show you how to do that. If you take a look at this orange packet, you are going to keep this orange packet in a safe place because it is all your references that you use for this class. It is the formula chart, so the first thing you turn to is the formula chart. We're going to start using those formulas next chapter. Okay, and then on the back we'll use those next semester. All right, then you see the z-table. This is what the z-table looks like. And so now I want to explain what all the parts of this z-table are. So this is the second orange sheet in your packet. So here we go. All right. On the edges of this information are the z-scores. Okay? So notice all the z-scores on this front side have what sign? What is the sign of all of these z-scores? They are all negative. If you have a negative z-score, where are you located on the normal curve? Below the mean. Very good. All of these places down here have negative z-scores. All right. So that's what this side represents. Okay? Now, let me explain to you what this top bar is. This top bar is just the 100th place. So the left bar is the whole number. Is the whole number and the tenths, and then the top bar is the hundredths. So, for example, if I wanted to ask you What's the number that corresponds with negative 1.85? Okay, so let's locate negative 1.85 as a z-score. Okay, so we're going to look here, come to negative 1.8, but I want negative 1.85. That is here. See, this number is negative 1.80, negative 1.81. This is negative 1.82. This is the number associated with negative 1.83, and so on. So the value I want is 0.0322. That's the number associated with negative 1.85. Okay, so this is your z-score that you just found. So let's talk about what this is inside. This number that you just found is the area, or the percent, or the probability, or whatever, below your z-score. Okay? These numbers in here are what represents this shaded section below your z-score. So for example, at a z-score of, let's say this is negative 1.85, how much is this area below the z-score of negative 1.85? How much is it? 0.0322. Very good. 0.0322. If you're going to put that in percentages, then that's going to be 3.22%. So this area is 3.22% of all the data that we've got in this curve, in this situation. Okay, so that's that. So I would like for you now to see if you can locate the z-score for positive 1.85. Positive 1.85. Where do you think that is? Other side, correct. These numbers over here are the positive z-scores. So since these are the positive z-scores, where are they located on the normal curve? Where are the positive z-scores on the normal curve? To the right, so this upper part. All right, so let's find 1.85. Is that 0.9678? Okay, so 0.9678. Okay, so tell me, what is 0.9678? So let's say that this is the z-score of 1.85. What's 0.9678 mean? Good, that's all the area below that z-score is, what was 96.78. Okay. So 96.78% of the data is located below that z-score. All right, now question. How much is this? Very good. It is 0.0322. How did I know? Why is this the same amount as this one over here? Because the shape is symmetric. Okay? Because the shape is symmetric. So I'm just kind of, is it a requirement to know that? Well, you kind of need to know your way around the curve. So here's what's happening. So again, here's what we just found out. The area below the negative 1.85 is the same as the area above a positive 1.85 because of the symmetry. Okay? All right, otherwise, you can subtract from 1. You did 100% minus your 96.78, then you're getting your 0.0322. Okay, very good. Now that we know the anatomy, or how to read the Z table, let's go to the question that we had posed here. What percentile is the husband's the husband located at in his department? So go find the z-score for 1.55. Sorry, it's not 1.55, it's 1.50. So what percentage is below him? Hello, what is it? Good. 0.9332. Okay, so this could also be translated to 93.32% if you want to think about that as a proportion of his department. So, somebody tell me what that means in context of this situation about the husband's salary and where he works. Go. Close. Okay, go. Correct. He's not making 90. Okay, so let me clarify. Now hold on, listen. One statement was made. He's making 93.32% more than the other people. That's not what it was. Okay. He is making a higher salary, so he has a higher hourly rate or higher salary or whatever it is than 93.32% of the people. Question, is it the people in the entire company? No, just in his department. That's relative to his department only. Okay, so he's making higher than 93.32% of the people in his department. Now, let's answer this question about the wife. So what percent of the employees in the wife's department earn better than her? Remember that her z-score was 1.25. If you look at a picture, and this was a z-score of 1.25, I want to highlight the section that I'm trying to find if I want the salaries better than hers. Where's that? What? And to the right? Okay, good. Sorry, can't hear you. So, to the right. Very good. If I can find how much area this is, then that tells me the percent of people that make a salary better than she does. English-wise, what should be? Okay. So how do I do that? I could. So hold that thought real quick though. So I can do it one of two ways. Of course, I can go to the 1.25, which is at 1.25. So 0.8944 is this part. 0.8944 is the gray portion below 1.25 z-scores. So to find what's above it, I can just subtract it from 1, and I get that 0.1056. Sorry, I'm not lining up my decimals, okay? Alright, so that's what you got here. So, question, in context, I want to know what this 0.1056 means. Okay, you ready? So, what does it go? Say it. Go. Correct. Correct. In fact, you could even go straight from this sentence here, the way it was worded. Look, 10.56, oh, percent's already said there. 10.56% of the employees in the wife's department earn better hourly rates than she does, than her. Okay, very good. All right. Now, Sky asked the question. She said, can't you just go to the negative? Yeah, you can. If I want to think the same amount as above a positive 2.15, I could think, what's the flip to that? What would be the flip side to this? Whatever is below negative 1.25. So if your brain works that way, then fine. Then you don't have to do any subtraction. So if I want to look below a negative 1.25, then I have to go to my actual chart here, where the negatives are. Let's find it. Negative 1.25, right there it is. 0.1056. Okay? All right. So there's your options of how to do that. So I want you to practice this. In fact, I'm going to come around and stamp you on your homework while you do this quick check. But I want to show you specifically how I want you to write things. Okay? So hold on. Before you get all settled with your homework for me to stamp, let's do one of these problems together. Here we go. Number 1, find the percent below the z-score of 2.13. So for each of these problems, I want you to draw a quick sketch. Let me show you where I want you to do that. Label it. Use correct mathematical notation, and then find the probability. So you also picked up with your notes this piece of paper here, which said normal notes day 2. Okay. All right. So let's do problem number 1. Problem number 1 said, find the probability, find the percent below a z-score of 2.13. Okay, so here it is. So here is the math language, okay? You know, math is its own language. Here's how you write that question with math symbols. Find the probability of a z-score less than 2.13. So that's the math notation of how to write that. And then you would put equals, and then we're going to find that out in just a second. But let's draw a picture. Okay? For this one assignment today, I'm going to make you draw a picture for all of the problems. You can see on your homework there, I attached 18 graphs. This is the, I'm sorry, but I'm going to be a stickler on this. Only this assignment will I make you draw them, because it's something that connects in your brain to make it concrete understanding of physically what's happening and what you are computing. Once you get that concrete understanding, then you can start doing things just abstractly in your brain and not have to think about it. You can visualize it. But this assignment only, I'm going to make you draw these pictures. So let's go ahead and label this. This is a normal model, standard normal model, 0, 1, 2, 3, -1, -2, -3. Okay, so we have a z at 2.13. That's about right here, and I label it. Z equals 2.13. And shade the area you're finding. Where is the area I'm finding? Less than. So you're going to shade that in right there. Now, go to your z-chart to find the answer. So here comes your z-chart. This is kind of getting a lot of writing on it, so let me clear that real quick. Okay, so I want the positive 2.13, so I got to go to the positive side and find the 2.13, 2.13 right here at 0.9834. So the answer to this problem is 0.9834. So 98.34% of the data is below a z-score of 2.13. That's what that's saying. Okay. So I want you to do the rest of these quick check problems while I come around and stamp you. All right, work on that. Let me show you guys the answers real quick, and then we're going to go on. Most of you got that here on this. Let's talk about number 5 and 6 really quickly. So here's how you notate number 5 this way. See how you're saying the probability that your z-score is less than 2.6 and greater than 1.6, okay? So that's how you notate it, to be in between two values. And so then you took this entire area below 2.6, so you found that value on your chart, the entire area below 2.6, and then you subtracted off the entire area that is below 1.6, and that leaves you with what's left. Okay? All right, and then that's the same thing you do for number 6 to get your 85.62%. Now, last thing is for me to show you how to do these on your calculator. So, let's take a look at your calculator. Yep, you can just get out your calculator. So, the format to do something on your calculator is to use this function, and I'm going to show you where that is in just a second. But you're going to use the function norm CDF, and then it has a parentheses, and you will go from, I'm going to tell you in a second, it'll go from one value, comma, another value. Okay, so here's what this means. Norm is, of course, referencing the normal curve. So on the normal curve, we are going to be getting the cumulative, that's what the C stands for, distribution function. Cumulative distribution function. Anyway, so that's going to give you the area, the cumulative area between two z-scores. So, if I want to go below, so let's do below first. If I want to go below, let's do number 1 was 2.13. Is that what it was? So, I want to go below 2.13, then I want that to be the highest z-score. So that is the one on the right side of the parentheses. And then what is the lowest value of going down to negative infinity? Now we have to simulate negative infinity because there is no negative infinity button. So if this is only 3 z-scores right here, 3 standard deviations, -1, -2, -3, then 99 z-scores is like simulating infinity. So when we put a -99 right here, that is simulating negative infinity. So here's where this is on your calculator. All right, ready? Second, bars. Bars is right here beside the clear. Do not use the number 1 button. The second one is norm CDF. That's the cumulative from -99. Comma is right above the 7. And then 2.13. Close it, and there you go. Now, if you have a newer calculator, so the answer is 0.9834. If you have a newer calculator, then it gives you a different screen, and it asks for the bounds. Well, guess what? -99 is your lower bound, 2.13 is your upper bound, and 0 is the mean, and 1 is the standard deviation. Okay? Hey, by the way, notice that that's the exact same value we got when we did this with our z-chart. Okay? Let's do this problem. Let's do number 4 on our calculator. We want to go z greater than 0.98. So that would look like this. So if I want to go above a value, then I got 0.98 is my z. I'm going above. So in my calculator, I put in norm CDF from one z-score to the next. What's the lowest z-score in my area? 0.98 is the lower bound. What is the upper bound if I'm going up? Positive infinity. And how do I simulate positive infinity? 99 z-scores out there. And that gives you your answer. Between is the same thing. So let me just show you real quick. If you did norm CDF from 1.6 to 2.6, that would give you the area between those two z-scores. So there you go. So you got your homework, part 1 and part 2. Okay, so let me show you those two areas. So for the one that is above, you will go second bars, norm CDF from the 0.98, comma, simulate infinity by going positive 99, and there you go, 0.1635. That is the value that you got on this problem when you did it with your z-chart. So let's do this one here that is in between. I mentioned it just a minute ago, but you're going to be doing the second bars, norm CDF, from the lower z-score of 1.6, comma, the upper z-score 2.6, close the thing, close the parentheses, and 0.0501, which you can see is what we got on this number 5. Okay? Alright, so that's how you do all those on your calculator. You can do the problems all the same way. So let's take a look real quickly, though, at your homework. I want to make sure that you do that correctly. So on your homework, I want you to make sure that you understand that it's important that you show your attached work on these graphs. I included all the graphs here with this. Okay, so I included all the graphs there. So again, on this assignment, it's very important that you draw your pictures. This is the only one that I'm going to really stress that you draw them. Now, the first part you should do with your z-chart. I want you to get used to still being proficient in your z-chart. The second part, you can use your calculator. So, for example, you're going to, on numbers 12 through 14, 12, 13, and 14 actually, you can use your calculator, but notice the information is given to you a little differently. It says here, you want to find between 176 and 185. Well, those are not z-scores, because z-scores are numbers like 1, 2, and 3, or any decimals in between there. So the problem is that you have to find the z-scores first in order to be able to do these problems. So let's do that for this first part here. Z equals your data, which is 176, minus the mean, 174, divided by the standard deviation of 21.5. Now, once you get that value, you then have the z-score for the left bound. Then you find the z-score for this problem in the same manner, 185 minus the mean over the standard deviations, and then you can do the calculator for the values between those two. Okay, so that is how you're going to be doing those problems for this homework, Chapter 6, Part 2.